Hello everyone, welcome back to another video. So today we will see solutions for Leetcode weekly contest 376. So first question, as usual, it's basically an implementation based question. So we are given a grid 2D matrix of n into n, and it contains values from 1 to n square, but as each in most of the integers appears exactly once, but a integer appears twice and b integer is missing from this range. So we have to find that ab and return them as a vector, where answer of 0 is equal to a and answer of 1 equal to b. So as you can see, this is the matrix 1 3 2 2. Now 2 is repeated twice and 4 is missing, so I written the answer is 2 comma 4. Similarly, here 9 is repeated and 5 is missing, so that is returned. So this is pretty basic, pretty simple implementation problem. I used a map, or you also can use just use 4 for loops, I guess. Brute force solution, it will still work, but I used a map and counted the occurrence of every element and initialized a vector answer with size 2. And if mp of I means the occurrence of I is 0, I will make answer of 1 equal to this current I, and if mp of I equal to 2, I will make answer of 0 equal to I, and I will just return that vector. So this was first question. As usual, pretty simple question. Now second question. So we are given an array of array nums and size is n, and we are also given k positive integer. Now we have to divide the array into one or more arrays of size 3 satisfying the following condition, such that each element is of nums should be exactly in one array, and the difference between any two elements in one array is less than equal to k. So we have to return the partition we made, and 2D, basically a 2D array in which we 2D array containing all the arrays which are there after partition. For example, this is the partition like 1 1 3 3 4 5 7 8 9, and if you check absolute difference between any two elements, it will always be less than equal to k. And if there are no such possible options, we have to just return an empty vector. Now let's just take this example 1 1 3 and 7 8 9. So also the n is of the given n is of multiple of 3, so size of the array is multiple of 3. So it is always possible to divide in the whole array into um, vectors of multiple vectors in which size of each vector is 3. So in this example, if I sort all the elements like this, so these are basically sorted elements in the from this vector. Now let's say I have to compulsory put this one in one of the vectors, right? So what is the possible value, maximum possible value which can come in the same vector of size 3? It should be 1 plus k. So basically, if this is the minimum element, the maximum element should be less than equal to this 1 plus k. And what is the optimal partition here? Optimal partition is here is to put next second minimum element. So for this one, I can put this in the middle and this in the last position. Now this becomes one partition. Now if we, this is only optimal partition. If we put any number greater than this, the possibility of that they will not satisfy this condition are higher. So I have to put this element only. Now similarly for these three, I have to put these three elements, and for 7 I have to put this 9. Now it might be possible that absolute difference between 5 and 3 means the minimum and maximum element might be greater than k. So we have to also check that for each partition, and if all partitions are possible, I will just return all those vectors, or else I will just return an empty vector. So let's see the code. So first I sort then array, sort the vector, then store n as size of vector, and I initialize an answer vector of 2D vector answer. Now for each I in I from 0 to n, I am jumping from 0 to third, so I am incrementing the pointer I by 3 after each iteration. Now I will check if a of I plus 2 minus a of I is less than equal to k. Now the maximum difference between the maximum difference of pairs between these elements will be always be between minimum and maximum element, which is a of I plus 2 minus a of I plus 2, which is maximum, and a of I, which is minimum. So I am checking if it is less than equal to k. I will just push that vector at any point of time. If this condition doesn't satisfy, I will just return an empty vector, and all the conditions are satisfied, I will just return the answer, which is the which stored all the vectors. So this was also pretty simple because there was very easy observation, and if you even see the sample test case, you would understand you have to sort the array. So next question is minimum cost. Okay, so this question was difficult for me because I tried different approach from most of the other users of Leetcode. So here we have given an array of nums of length n, and in one move what you can do is you can choose an index I and a positive integer x, and I can add absolute of nums of I minus x to total cost and change the value of nums of y to x. And now we are also given two an palindromic numbers definition. So a palindromic number is a number when we reverse it, this is equal to original number itself. For example, 121, if we reverse it, it's still 121. And we are also given equilindromic. So this an array is considered equilindromic when all the elements are equal and they are equal to an integer y, such that y is palindromic number which is less than 10 raised to the power 9, and we have to return minimum possible total cost to make nums the array equilindromic. So here let's say see an example. Here as you can see the array is 1 2 3 4 5. Now we can always make all the elements equal to 3. So if I have to make this 2 equal to 3, I have to choose uh, x as 3. So cost will be increased by 1 and this element will become 3. Similarly here I can make it equal to 3 plus cost will increase by 2. Similarly here I can make equal to 3 and cost will increase by 1, and here cost will increase by 2, so total cost becomes 6. So this was the solution for hand running of the solution. Now we were able to make it 3 because 3 is a palindromic number, and similarly in second test case if we 11 if we try to make all the elements equal to 11, the total cost which required to make it equal to 11 is 11 itself. So and 11 is also a palindromic number because 1 1, if you reverse it, it still is 1 1. And in the third test case we try to make it equal to 22, and the total cost for it is 22. Now one of the approaches, it's based on an observation. So let's say this is the case test third test case. We write this as 22. I have written it sorted in sorted order for some observation only. So it is always optimal to make all the elements equal to one of the element um, to one of the element in the array, or middle we can say middle equal to somewhat element which is in the middle of all the positions. Let's say here 22 is already palindromic. Let's first take all case in which such that all the elements which are present in nums are palindromic. As you can see here, all the elements are palindromic. Now you can derive an observation that it is always optimal to make all the elements equal to one of the elements of array. So I can make that equal to 22 or 33. Now if you make them equal to 22, this absolute difference for all the elements to the right and this absolute difference to all the elements to the left is the total answer for our question. Now if I try to make all the elements equal to 33, now the point here is there is additional difference required here, which makes the total cost higher than previous option. So it is always optimal to choose the middle element and make all the elements in the array equal to that middle element. Now let's say the element is not, so here thirteen. So let's say here the middle element is 13, but it is not a palindromic number. So what we have to do, we have to choose the element which is closest to 13 and less than 13, which is palindromic. So for 13 it will be 11. So 11 is palindromic and closest to 13. And also we have to check the greater element which is greater than 13, and so it will be 22, probably 22. So these are the two possible options. So we have to try both those options and find the minimum cost between these two elements. So this is pretty intuitive solution. Now I wrote a different solution. I was not able to prove this in contest. I also didn't understand how it works. What I did was, so here we are given uh, this 10 is to 1 9. So for generating all the elements which are palindromic and less than 10 is to 1 9, we need a for loop of 10 is to power 5, and into 10 additional I can generate all the palindromic numbers in this complexity. Let's say 10 is to power 6, equivalent to 10 is to power 6. And For each element which which is possible in this 10 raised to power 6 for loop, we will use a combination of prefix sum and upper bound or lower bound or minus h any searching algorithm. I used upper bound and calculate the maximum value, calculate the total cost using these two elements for each palindromic number in this for loop, and we will just take minimum of it with our answer variable. So I use this technique. Now I got a lot of TLEs in this question. So if you think of it, the complexity of this becomes 10 raised to power 6 into log of n which is 10 raised to power 5. So logically it should not give TLE, but I needed to fine tune the solution somewhat to make it pass the test. This second solution which I explained earlier, it will easily pass, but this you have to fine tune some solution. There is problem with string to integer conversion, with string concatenation. I converted each number into string and then made it reverse, added it again. So I used a lot of functions. That's why also probably there was I needed to fine tune the solution. Now you can implement it with this easily, but I will explain also this how this works. So basically I have to generate all the elements from 10 raised to power 9. Now what is the biggest palindrome in between in 10 raised to power 9? uh, it is 8 times 9. Now if I know this first half first half of the number, I also know this. So what if I generate only this and just reverse all these elements after that? For example, let's say I generate 1 2 3 4. Now if I reverse this 4 3 2 1, now I got the 8 digit palindromic number. Similarly for um, let's say for odd digit we have to find 7 digit number. So let's say I generate a number 3 4 6, and as the size of the string is 7, I will write 643 here, and this can be anything from 0 to 9. So I have to find all those combinations also, and also all these even combinations, and for each element I basically do a prefix sum plus upper bound. Now prefix sum is pre-computational technique, so I generate a vector where pf of 0 is a of 0 and pf of 1 is a of 0 plus a of 1. Similarly, pf of I is a of 0 up to a of I. So this is basically prefix sum. Now how I use it in this? So let's say a1, a2, ai and ai plus 1 and an. So let's say for element x I have to calculate the number total cost required to make all the elements equal to x. Now for this a1 the cost is absolute of x minus a1. Similarly x minus a2 and absolute of x minus an. Now if I have to remove this absolute, I have to find all the elements which are less than x, and so let's say from a1 to ai all the elements are less than x. So this is sorted array. I have to also sort this array at the start, so that is also we have to sorting is also required. Now all these elements are less than equal to x, less than equal to x. So this equation becomes x minus a1, x minus a2, up to x minus ai, and ai plus 1 to an are greater than x. So this becomes ai plus 1 minus x, and this becomes a of n minus x. Now if I compute all this, it will become equal to I into x minus p of prefix sum of I, and this will become uh, total sum of array minus p of I minus uh, n minus I into x. So I got this formula for total sum. If you can imagine how I calculated, so prefix sum x minus a1, x minus a2, x minus ai. So I will take all x common, it number of x is equal to I. So I into x minus a1 plus a2 plus a3 up to ai, which is prefix of I. And for calculating sum from ai plus 1 to an, I will just I will just take the total sum and subtract the first I elements, which is prefix of I, and subtract number of x which are present in this formula, which is n minus I into x. So this is the total cost, and I will compare this cost with, take this cost minimum with our answer. So I use this logic. It should easily pass because the complexity is 10 to the power 6 into log of 10 to the power 5. So but I needed to fine tune this solution. I have made 11 wrong submissions on this question, but very less people solved it, so it kind of worked out. I won't explain this code, it is too big, but if you understand this logic, you will understand also this submission. So I will share the my submission link in the description. Now moving on to fourth question. So here we have to make, we are given an array as nums and also given k. Now we can either increase or decrease nums of I by 1, and the score of final array is the frequency of most frequent element in the array. Now we have to return maximum score you can achieve. So we have to perform k operation, at most k operations, and we have to make most of the elements in the array equal. So for example, in 1 2 6 4, let's say I increment this uh, 1 by 1, so it becomes 2 2 6 4, and I increment this 4 by 2, so it will become 2 2 6 2. Now the maximum occurrence of an element here is 3, so our score is 3. There is no other possible way to make it greater than 3. And similarly here 1 2 4 4 4, here k is 0, so basically we have to just input output my maximum occurrence of element, which is 4, and answer here is 4. So if you got this, understood this median proof or approach, you will also understand this. So basically this is a repetitive third repetition of this third question, I think. So let's say in first example 1 2 4 6, if we have k equal to 3, what it is always optimal to either make first three elements equal to each other, or second to fourth elements equal to each other if answer is 3. So let's say I have to make here, let's say I have to make three elements equal at least. So I have to make all those first three elements in the sorted array. Second option is to make elements from second to fourth equal, and there might be another option where I have to make from third to fifth. So this kind of observation gives me a sliding window approach. And how to fix this key? So for fixing this key, let's say if I can make all the elements three, at least three elements equal to three elements equal with this value of k. I can also make two elements equal. I can also make a single element is already equal. So this kind of observation gave me binary search uh, solution. So what I did, I used a binary search for fixing the window size, and I used a sliding window approach for after fixing each k. I have to find if it is possible to uh, set, set all the elements in that window equal to a single element. Now, so let's say D is the current element in binary search. Now the first window will be from 0 to j equal to d minus 1. Now as we discussed earlier, it is optimal to make all the elements equal to median because it gives minimum cost. Now the median here will be I plus j by 2. So a of I plus j by 2. So we have to make all the elements equal to this element. Now similarly, as we used prefix sum logic here, for all the elements before this, let's say a of I up to a of I plus j by 2, and all the elements after this a of j, I can calculate these two, number of the total sum as prefix sum and the number of elements which are present in this equal to I plus j by 2, let's say it is as md, which is basically medium, minus I into a of md, and I have to subtract this prefix sum. If you understand that, you will also understand this. And similarly I have to use it for a of j, and if I the total cost required is less than equal to k, so I can make this window a size of array which has a size d, and all the elements I can make them equal with within this key. So if d is possible, I will go in the range d plus 1 to n to check if there are other option possible. If d is not possible, I will go to check other values from 1 to d minus 1. Simple binary search on answer. So let's see this code. So first I take the prefix, sort the array, and answer will be always at least one because at least one element will always be equal, and I will make low equal to 2 and high equal to n, because maximum possible answer can be n because n is the number of elements. And I will fix this sliding window size as d and start our sliding window from 0 to d minus 1. I also initialize the boolean. Now while j less than n, so right side of our sliding window is less than n, I will calculate md, which is middle element, and number of elements which are less than middle are md minus I, and number of elements which are more than md are j minus md. Now this is the formula for e of md this is to calculate how many times we are adding this a of md and subtracting this prefix sum. So it will be equal to a of md into less number of, so less integer represents number of times we are adding this element. Now if md minus 1 is greater than equal to 0, I have to subtract that prefix sum. So all the elements before md, I have to subtract them. And now for right side, I have to first of all add this prefix sum from j to md plus 1, all the elements between them. I have to add the sum of that element and subtract a of md into more elements. So this is x and this is number of elements, so I have to decrease m into x, where m is the number of greater elements and x is the value of a of md. Now after calculating this sum, I have to check if the sum is less than equal to k, and if it is, I will make found equal to true and break this while loop, or else I will just increment I plus plus and j plus plus, move the sliding window more to the right, and if answer found is true, I will make answer equal to d, low equal to d plus 1, or else high equal to d minus 1. So this was more difficult than normal fourth question of Leetcode contest, but not so difficult if you are able to solve third. You will also probably solve fourth because they are very similar questions. So I will also link solutions this time because codes are huge. And thank you for watching. If you like the video, please subscribe and like.